Lesson 4, intersection and union of two sets. So intersection, if you were to imagine your Venn diagram, the intersection is the point where our two circles match. So it's points that are in both set A and set B. And the way that we denote this is I don't know what shape that is, upside down U, B. And the way that I remember this is set A and B. So it's in both A and B, and I remember that because the upside down looks like an A. So I remember and. So set A and B. So example 1, we want to write the intersection of set A and B in set notation. So what we're looking for is the numbers that are in both set A and B. So we have a 2 in both sets, we have a 4 in both sets, and a 6 in both sets. So set A and B, we have the numbers 2, 4, and 6. So the way that we write this in set notation is A intersection of B is equal to 2, 4, and 6. And if we were to find the number of A intersect B, it would be 3. We have 3 terms in the intersection. The next we have is the union. So if you were to imagine your Venn diagrams, it's everything that's in A and everything that's in B. It's both of them. So the way that I remember union is that it is a U. U for union. So U means A or B. That's the word you can think of. So it can be in A or it can be in B. And it's important, though, that you don't double count your intersected area. We don't have to write it twice. So for this one, the numbers that are in A or B are 1, 2, 3, 4, 5, and 6. We also have 2, but we already have a 2. 4, we already have a 2. 6, we already have a 6. We also have 8, 10, and 12. So these are our numbers for our intersection. The way that we write it in set notation is A union B is equal to 1, 2, 3, 4, 5, 6, 8, 10, 12. And the number of A union B would be 9. We have 9 terms there. And a way that you can figure this out is if you take the number of A and you add the number of B and you subtract the number of A and B, you'll get your union. I'm having a hard time. Because you don't want to double count A and B. So we know A has 1, 2, 3, 4, 5, 6. We know B has 1, 2, 3, 4, 5, 6. And we know the union from our previous example had 3. So we have 12 minus 3 is our union, which is 9, just like we got here. So that is another way you can solve to find your union without having to write out all the terms. It's easy now because there's only 9 of them, but when you have hundreds of them, you don't want to write them all out. A minus B are all the elements that are in A but not in set B. So if we write A minus B, the ones that are in A but not B are 1, 3, and 5. Everything else is in B. So it'd be 1, 3, and 5. And the number of A minus B would be 3. Now we can do it backwards too. If we wanted to do B not minus A, things in B but not in A, we'd have 4, not 4, not 2, not 6, but 8, 10, and 12. So the number of B, not A, would also be 3. So it goes both ways. It matters the order. Whichever one comes first, that's what matters. This is similar to complementary sets. Okay, example 4. If you draw a card at random from a standard deck of cards, determine the following with set notation. So we have U, C, S, H, and D. So this is part A. So U is the ultimate, or is the universal set, the ultimate set. So it's all the cards when you draw from the deck of cards, which is 52. So we know that that's going to be 52. C would be when you're drawing a club. S would be when you're drawing a spade. H would be when you're drawing a heart. And D would be a diamond. So for part B, we want to find the number of each of these sets. So we know n of our universal set is 52. Now, because every deck of cards has an ace, a 2, a 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and a king, that means that there's 13 cards of each suit. So the n of clubs would be 13, the number of spades would be 13, the number of hearts would be 13, and the number of diamonds would be 13. For part C, we want to find the union of drawing an H or an S. So what is the chances of drawing a spade and a heart? So remember, union means spade or heart. So if we have our 4 decks of cards, there's 13 of each. We have spades, hearts, clubs, diamonds. We want to find both this circle and this circle. So we have the n of S union H is equal to the number of S plus the number of H minus the intersection. But since our circles don't intersect at all, they're all completely separate, we don't have to minus our intersection. So we have 13 plus 13 is 26. So really what it's saying is 26 out of 52 cards, that's your chances of drawing a spade or a heart, which makes sense because it's half your cards. To find our intersection though, S and H, we would want to find when you could draw a card and it's both a spade and a heart. That is what our intersection would be. So because you could never draw a card and have it be both a spade and a heart at the same time, these are all disjoint from each other. None of them intersect at all. So our intersection is 0. We have no intersection. And what this is called is it's mutually exclusive. It means that each event is exclusive for that event. You can't have more than one thing happening at once. So you can't draw a heart and a club at the same time. I realize that doesn't look anything like a club. Example 5. You survey 34 people at the gym. We know that 16 people do weight training 3 times a week. 21 people do cardio training 3 times a week. And 6 people do fewer than 3 times a week. And how are we going to interpret this data? So we're going to make a Venn diagram. So we have a Venn diagram, we have people that go to the gym, so let's call G our universal set. And we have people who do weight training, people who do cardio training. Let's make this bigger. Weight training and cardio training. So first off, we know that 6 people don't do either of those things. So these are in our universal set, but they are not part of our circles. It's not part of our union or intersection or W or C. We know that the weight training people have 16 and the cardio training people have 21. And all together, it's 34. So we want to figure out what our intersection is. So we have the number of G is equal to 34. The number of weight training is equal to 16. The number of cardio is equal to 21. Now we want to figure out our intersection. So in order to find our intersection, we want to find W and cardio. Weight training and cardio. Because we want to figure out, that would be our middle section. We want to figure this out. So in order to find that, we first need to find our union. We want to figure out how many people in total there is. So we want to find W or C. So W or C would be N of G plus N of G. N of W plus N of C. That's going to find our total union area, but we're going to be doubling up on our intersection. So we have 34, just kidding, 16 plus 21. So we know that there's 37 people. And we know that there was 34 minus 6 people in our circles. So that would be 28. So because this number and this number doesn't match, that's because we are missing our intersection. So the way that we write this out, this is our formula. So the union is equal to each number minus the intersection. So we know that altogether the union has to equal 28. So 16 plus 21, just kidding. We take the total, 34 minus 6 to get 28. So we know that in the circles, there's 28 numbers altogether. We know N of W is 16, and we know N of C is 21. But we don't know the intersection. So all we're going to do is solve for this. So we're going to the 16 and move it to the other side, and the 21 and move it to the other side. So you have 28 minus 16 minus 21, and you get negative 9. And this is equal to minus N of W and C. So all we're going to do is flip our signs. So the intersection of W and C is 9. So we put 9 here. Now we need to find our other two sections. So for W, we have 16 minus 9, which is 7. And for C, we have 21 minus 9, which is 12. So we're able to see that 12 people only do cardio, 7 people only do weight training, and 9 people do both, and 6 people don't go to the gym 3 times a week. Okay, example 5. This has to do with a high school team that has 16 different sports. And we want to explain which of them use balls in their sports, which of them use some sort of implement, so like a racket or a bat, which ones have a ball and an implement, and which ones have neither. So we're going to go through the list and put them into our Venn diagram first, just to organize this. So we have badminton. Badminton doesn't use a ball, but it has an implement. Basketball has a ball. Cross-country running doesn't require anything, so cross-country. So what I want you to do is I want you to pause the video and try and put all of these into the circles. So you should get this as your answer. So basketball, football, rugby, soccer, volleyball all use balls. Tennis, golf, lacrosse, softball use both. Badminton, curling, hockey, skiing, frisbee use implements. And wrestling and cross-country skiing use nothing. So what we're going to do is we're going to find U, which is the universal set. So that would be all sports. We're going to find B, which is uses a ball. And we're going to find I, which means it uses an implement. So we're going to find the number of each of these things. So N of U, we know, is 16. There's 16 sports. N of B is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 things that use a ball. N of I, implement, is 1, 2, 3, 4, 5, 6, 7, 8, 9 as well. And now we want to find our intersection area. So N of a ball, I don't know, I wrote a ball and an implement would be our intersected area, which is 1, 2, 3, 4. So we have 4 numbers that are in our intersection area. If we were trying to find our union area, we want to find all of our terms in B and I. So we would just count each term once. So it's not the same as 9 plus 9. That doesn't help us. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And the way that we remember this is we take the N of B plus the N of I, and we subtract N of B and I. I am running out of room. So we'd have 9 plus 9 minus 4. So 9 plus 9 is 18, minus 4 is 14. So that is how you use the formula. And the last thing would be the number of B or I. We want to find the complement of that. So that means the number of things that are not in B or I. And that would be our outside numbers, which is 2. So there's all of our important information.